Hi, welcome to the Hadoop and Big Data web series. Here I am Suresh and I have been responsible for delivering the training since over the back of thousands of people, and now I am very excited to reach much more audience with the help of Durga software solutions. And let's start the introduction to Big Data and Hadoop technologies. Here the term the Hadoop which refers from the problem of big data, which is the most important buzzword which needs the most common thing in the 21st century. Let's think about what is big data and what are the features of big data, how to control this big data with the help of Hadoop. And here the big data is a term normally which you are saying that as a huge amount of data, and if you go in detail level, the subjective term big data which refers to things like if you have a data beyond the storage capacity to process any machine or any processor, those data we are calling as a big data. If you want to learn more about big data, means obviously we have to take the help of IBM's 3 V's challenges or 3 V's principles to better understanding about big data. The main principles of this big data with respect to the IBM, those are volume, velocity and variety. These 3 V's principle as given by the IBM, and nowadays we have most important challenge also facing, and that is also we have to consider, that is veracity. Why we have to think about all these 3 V's, all these 4 V's means, if you want to learn about more thing about Hadoop, and if you want to understand what is exact big data and what are the exact problem in this nowadays, means we have to get a complete understanding of what is the major concerns regarding this data with respect to these 4 principles. Let's understand more in detail what is the volume, velocity, veracity principles with respect to the big data. Here, if you take the data, you are saying that if you say that if you are considering this volume of the big data principle, means here we have to consider the size of the data. Suppose if you consider the size of the data as the petabytes of the data, if you have, it means we cannot have that much of storage capacity nowadays. Before going to understand, let's have let's have a brief understanding about these 4 V's principles, then I will tell you that in detail what is volume, velocity in detail. Fine. Here the volume will refers the size of the data, and velocity here we have to on which speed we have to control, and we have to analyze the complete understanding of big data. And here variety you have specified, we have some of the types of kinds of data, we have the things are there, what types of data we have to consider and why we need to consider all these types. And velocity will refer the things very related to the consistency of data generation. Let's look about in detail what is volume concern about in the respect to the big data. Here I am saying that the size of the data is already reached on top of the beyond the storage capacity. How we can take it out that as a storage capacity that is already reached? Suppose if you consider some of the data generations, if you consider volume principle of big data, means here we have huge amount of data, right? For that purpose itself I am saying let us consider out how this much of data we have generated since over of last previous years. Let's have a simple lookup. Suppose nowadays we have lot of more MNCs are working on the internet, right? Let's have things like, let's consider the Google and Facebook and Twitter. I hope you guys are there, right? You guys are remember, you are well aware about this Google and Facebook and Twitter, these companies. If you think about how much data is this generating in the daily activities, the Google per day it is generating 20 petabytes of data in a single day. If you consider how much amount of data we are generating as much of in respect to the months and years. And Facebook is also generating 15 to 20 petabytes of data per single day itself. and Twitter. We have lot more social websites and e-commerce websites, lot more things are there. eBay, these are the major contribution, they are giving the contribution to the big data problem with respect to the solution. We cannot say that these are these things, these companies are doing wrong and the kind of things. We have to control this. We cannot control this data generation unless we have to maintain this data generation by inventing by any technology or any algorithm. For this purpose, we have taken any one of the things. We have already said, we have given the examples as Google and Yahoo. These are the major search engines. They are generating, at least they are maintaining 20 petabyte data of generation per single day itself. And e-commerce websites like eBay and Flipkart, these websites are giving minimum to 10 petabytes data per single day itself. We have lot more things are to deliver, which gives the prominent importance to the huge amount of data generation. If you consider single airline which is located in the United States is generating 20 terabytes of data per single hour. Fine. If you check it out, how many hours are the US airlines are running in over the entire 24/7, and how much the data we are generating per single day or single month. You can consider a lot more sources. I have given already the social websites. If you take any government, e-governance, we have lot more principles which is related to which is proportionally increasing the data generation. The only one consideration we have to maintain is we cannot control the data with respect to the data generation, but rather than we have to maintain and we have to concentrate how to storage on this much of huge data and how to perform the processing logics on top of this huge amount of data. For this respective itself, we have to consider some of the most challenges and most of the solutions with regarding of big data with respect to the volume. I hope you guys understand that we have huge volume of data generations is happening in this 21st century. For that purpose itself, we have to consider this much of huge data is we are saying as a big data too with respect to the volume principle. Let's take that. I am saying that 20 petabyte of data we are generating, and I am saying this is the big data. Fine. Don't we have the capacity to maintain this much of petabytes of data in the traditional architecture? Means no. We have the traditional architecture with the RDBMS, relation database management systems. We have the Teradata, and we have some of the data warehouse techniques also we are maintaining in as the traditional architectures. It has the limitation to up to gigabytes and exceeding to the terabytes. If you want to proceed on more of these petabytes and exabytes or zettabytes or yottabyte means we cannot control the things. In future, we cannot expect that this is what the exact data we can generate. I cannot check it out. The Google is generating only 20 petabytes in the year of 2020 also. Obviously, it is giving more than that, more than the capacity of which is generating a single year itself. If you consider with respect to the IBM, if you consider we have from 1990s we have the major internet generation is happening, and we have the environment is happening here. If you consider now we are in 2016. Now if you consider the entire data generation is, if you taken as 100% of data generation which is happening in the world, means the major 90% of data which is generated in the last 5 years itself. In between 5 to 6 years itself, we have the most of the 90% of data which is generated in the perspective to the entire world data. Why we have this much of huge data generation is happens with this last 6 years means obviously everyone knows that if you have the internet activities are increased in last 6 years, and everyone is using as the smartphones, and everyone is looking about the data creation. Fine. And we have the Facebook, and these activities also related circulated among all over the world in between these past 6 years only. We have every country is looking up governance. Why means it is what it means, every individual paper document you are converting into a economic file. If you want to move all these things means obviously the data is also we have to keep it out in any traditional architectures. But do we have a efficient architecture to maintain this much of huge data? Suppose we are in 2016. Can we expect what it happened about 2020? Can you expect what about it will be happens with respect to the 2050? Can you really suitable to maintain that much of huge amount with regarding to the future years? These all are the major solutions, major problems, major questions we are facing in the real time. In the real time, we cannot say that as the production environments, we cannot say that we are expecting only terabytes of data, gigabytes of data. Sometimes we may receive some 100 terabytes of data, some petabytes of data also we may receive it from the clients. If you want to store all these things, means we need a particular environment to store and process. But till now we have seen a lot of algorithms and lot of things are there, right? Those are unable to fit to maintain all these things, and those are unable to maintain the mechanism which is with respect to the 50 times which is data generated, which is we have the data, actual data which is in 2020 and 2050. For that purpose itself, I am saying this maintaining huge amount of data with respect to the volume concern, the big data, I am saying this much of data is I am saying as a big data. Fine. This is all about some volume concern which is related to the size. Next, velocity. If you consider this velocity means, yes, I will tell you about that velocity. Before going to understand about this velocity, let me take in some introduction. Something like let's take one use case. Suppose I have one storage device, fine. Its capacity to perform a simple searching operation with regarding to the 100 records is 30 seconds. Fine. Suppose if I suddenly gave some 1000 records, can you expect within 30 seconds or more than 30 seconds? Obviously, it will take more than 30 seconds itself. Let us consider the value should be equivalent to some 50 to 60 seconds. Fine. Okay. Suppose I am directly giving the 10,000 or 1 million records to our existing system. Means we cannot control. We cannot say that it will be happens within minutes. It will be obviously it will take it will into hours. Fine. See, nowadays in 1990s and 2000s we have the data which is related to the any organizations. Their data volume sizes are related to this data only. They have the only hundreds of records or thousands of records. But now each and every company is maintaining holding the data with respect to the millions and billions of the data only, users data only. If you want to search about all this data means, do we have a sufficient processing techniques regarding the machine? Fine. Suppose in the year of 2005 and 2010 we have some of the data with respect to the storage capacity and search engine. With respect to the Google is holding the data. Suppose let us take it out as the Google is holding the data as 100 terabyte in the year of 2005. Fine. Obviously in the 2010 it may holdings to the data size is 1 petabyte. Suppose let us take an example only. These are the examples, not the exact figures. Suppose in the year of 2015 it may crosses to the 1 zettabyte or something like 100 petabytes. Like this we are generating the data. Suppose whatever the data volume of the data we have to generate the search engine results within a fraction of seconds only. How we are achieving these things and how it is we have to implementation of these things means we have to take the concern of velocity. It is not the only problem of Google or any top MNCs. We have, if you consider any organization, the velocity of this data generation, and if you want to process those data means every client is requested and every client is asking about the speed of data retrieval. If you want to maintain these both the concerns means we have to take the challenge of velocity with respect to the big data. We have to find the solution. Obviously we have the solution as the Hadoop. It's not the part. Let's think about the variety concern. What is meant by variety, and do we really have the types of data? As much as possible we are generating the data generating the data from different huge sources. We are expecting that some huge amount of types only. Suppose I am generating the data from different types of domains, like search engine domains, and we have the social networks, and we have healthcare, we have e-governance. Lot of sources from lot of sources I am generating the data. Is all the data types and all the data is given and taken care by the only single type? Is like some textual information, or it is in a binary information? No, we have lot more types with respect to the types, varieties of concern. Those are majorly we are saying as structured, unstructured, semi-structured. Why we have to consider these all the major considerations to the types of data means the holding is type of data, huge amount of data, it is not the major principle. We have to hold how much of the data we are generating, and in whatever the type of data it is coming from the client or resource. Suppose let us take it out as the example for the structured data means normally we are saying as a RDBMS tables or something which is in a well flexible format. Suppose I am saying as the RDBMS tables are the best example for structured data. Till now what we are doing means whatever the data we are generating as the structured, unstructured and semi-structured, we are converting the entire data into the structured, and we are keeping the entire data in our tables as part of the RDBMS storage capacity. But here we have the real capacity to maintain unstructured, semi-structured means let's have things. Here as a normal table structure, so tables data if you want to maintain means we have the well-known RDBMS, and we have some more data warehousing techniques. But the thing is, if the data is coming from the huge amount of data, that is what we have to consider. Yes, unstructured means we have I may give a lot more examples like images and videos and MP3, MP4 files. And we have a lot more, the resources are there. If you consider a lot more images of the lot more document file extensions are still unsupportable for the data storage and as part of the traditional architectures. The storing of some 100 terabytes of textual information is completely different from the storing of 100 terabytes of image or any video kind of file. For that purpose itself, we have to take a look about how to store this unstructured data. And if you consider semi-structured means it is by comparing with unstructured, the data is about the semi-structured, it is well good for maintaining the data with respect to the storage. Here semi-structured data means it is best example for XML data, and suppose sometimes your Excel data, which is you are getting the data from the Excel files, it is also we are saying as a semi-structured. With respect to the structure, it is not that much of huge things, but it is also XML kind of things, Excel kind of things. It is giving the format it is in the flexible format to perform any storage or any processing techniques. For that purpose itself, the maintaining structured data is very simple rather than with respect to the semi-structured and unstructured. But if you consider the data generation, we already seen that how much of data generation we have generated, right? Suppose if you consider this is the data we have generated till now, fine. About of the entire data generation, if you consider only 5 to 10% of data is structured, and most of the data and remaining 30 to 40% of data is semi-structured. Remaining entire data we are saying as a unstructured data only. Your daily, everyone is giving the tweets and posts, they are taking the selfies and put it in the Facebook, everything which is related to the unstructured data kind of things only. If you want to maintain this unstructured data do you have really supposed to maintain that much of huge storage capacity with respect to the storage things? That is what we have to think about with respect to the big data concern. I hope you understand what is the main thing, what the importance of to consider these types of variety principle with respect to the big data. And here, yes, I will tell you that as in the solution part, do we really supposed to handle this unstructured, semi-structured or not? It will come under in the next session, in this next topic itself. On top of this, these 3 V's are majorly given by the IBM as the major important features and challenges for the big data. with respect to the storage and speed and the variety kind of data generations. And veracity is also, it is a popular nowadays in the 21st century as the term which is we are mentioning that inconsistency with respect to the data generation. We are not maintaining the consistency. We cannot maintain the consistency with respect to the data generation. Today I am saying that I have a 1 terabyte of data with respect to from my client means I cannot surely give the recommendation to as my storage team or my architects to maintain a 2 terabytes or single terabyte itself as the part of tomorrow's data. For that concern itself we cannot, and sometimes if we are generating the outputs for the any our traditional architectures doesn't give the results in terms of consistency. For that purpose, to maintain the consistency with respect to the data generation and data analytic performances, and both the things if you want to work out means we need one new algorithm to maintain consistency of a data generation and data analytic performances. This is what the major 4 V's principle, 4 V's challenges we are taking with respect to the big data. The final thing what we are saying about the big data is, as the big data, it is referring as the huge amount of data which is coming from different types of sources and having the different kind of variety kind of data with respect to the speed and consistency. These are the major things we are talking about big data. And we have seen a couple of reasons and couple of things regarding big data. Let's check it out. What are the challenges and what are the possible solutions we found in the 21st century? We found Hadoop as the best solution in 21st century as part of the finding a big data problem. How we can say it as a Hadoop as the best solution for a big data, and do we really satisfy all these challenges by big data?